We connect this oscilloscope to computer with the USB cable, for data transmission and power supply. So you don't need another power adapter. If the scope is connected when the software is opened, the software automatically turns on the device and starts real-time acquisition. A plug-and-play message will show up to inform the device arrival or device removement on Windows OS 10. Red light indicates the state of power supply. The green light blinks while transmitting. On the most convenient way, we connect to a standard reference signal to display your first waveform on the screen. The signal is a square wave with amplitude of 1.5 volt and a frequency of 1 kHz. By default, the probe is set to X10 GHz, so the waveform displayed is small. We can switch it to X1 GHz. In X1, probe has a 6 MHz bandwidth and 5 to 5 volt input limitation. In X10, probe has a 60 MHz bandwidth and 50 to 50 volt input limitation. So on X10, we can adjust the probe for better frequency characteristic and wider bandwidth. With a tiny board driver in the package, we can adjust the compensation trimmer until we get the proper square wave. Now, this will get the overcompensated and screw to undercompensated. Now we will get the proper compensated square wave. Here, the proper compensated. Now we see the button in the lower right corner. We can click to start or stop the device. Once we stop the device, scroll bar showed up here. I'm sliding on it. You can slide left or right in the entire data buffer to show a new area of interest. You can find some special waveform details. You can also directly pressing on the left button on the waveform to left or to the right. You can also judge the 0 voltage baseline position, drag it up or down. You can also right-click the menu to select reset. Reset the 0 baseline position to the original position in the middle. Here we select the cursor measurement. You can drag a new position, the horizontal or vertical marking lines to show the data measurement. High resolution mode, average multiple agent state sampling produce a averaged sample. Peak tech mode finds the mark. In this section, we'll see how to enable and disable a channel and how to select company mode. Now, channel A enabled. Now, channel A disabled, channel B disabled, channel B enabled, channel A enabled. Channel A is AC coupling, DC coupling. Channel B is AC coupling, DC coupling. Now here are some examples. DC coupling for A, DC coupling for B, AC, and AC for A. You can use the AC mode. Now this section is about time knob control. Both channel A and channel B share the same time knob. The scale value selected by the time knob represent the time span, horizontal division in the waveform drawing area. With the same input signal we showed in this video now, we change the knob clockwise. The smaller time scale we select, the sparser waveform displayed. You can see now we counterclockwise select. The larger time scale we select, you can see the denser waveform displayed. Now we get the proper selection. You can also get some more selection in this list. About voltage knob control. Both channel A and channel B has its own voltage knobs. The value selected by the voltage knob determines the voltage span of each vertical division in the grid. Now we will see some different amplitude signals, for example, or a sine waveform of 0.4 volt, for example. Now, a sine waveform of 150 millivolt, for example. We have two kinds of zooming in operations. When this zoom in button is clicked, we can drag the mouse to select and release it to zoom in. Let's do it again. We can drag the mouse and release to zoom in. We can do it again and again until we are satisfied. Click this. You can also use this ruler tools to measure the time span of voltage span. Use this reset button to return to the original state. Now we see the x-axis zoom in. Click this button. We can also drag the mouse to select and release to zoom in only in the x-axis. This is x-axis zoom out click. Every click by it, we can zoom out until it returns to the original state. The waveform recording function is very useful when the signal needs to be saved for further observation or for offsite analysis. Now click this button to save to set the number of frames to record. Now click the rec to record. It's very simple. Now it's recording. The rec button is keep flashing. Okay, it has been done. Now we remove the real-time signal and open the file we saved. So open, and now it's playing back. We can also glance at the waveform frame by frame to stop, start. 上触发功能，我们可以调触发电瓶到一个合适的位置，然后选新稿按钮。我们等待一个突发的一个触发事件。现在触发事件来了，一个方波穿过了触发电瓶，被我们捕捉到了。通道的数学运算部分，做数学运算必须两个通道同时开启，才能对两个通道做运算。像现在紫色的部分是A 加 B。然后现在绿色的展示的是 A 减 B， 但你可以选择 A 乘 B， 在下面菜单里头还会有 A 乘 B。对，它就是棕色的这个波形。然后你可以选择AB， 就是 XY 绘图，也就是我们课本上讲的里萨如图形。